Hello and welcome to my YouTube channel Electrical Hub. Here we are going to discuss about the transformer commissioning test. This is the part 1 of the transformer commissioning test video. The rest of the part will be discussed in the next video. Here we are going to discuss the basics of the transformer insulation resistance test of transformer. How to do that, with what measure, we will discuss. Pi&Dar test of the transformer, polarization index and dielectric absorption ratio. Then magnetic balance test and voltage ratio test. These all the tests can be done by critical equipments, but if such equipments are not available, it can also be done with the minimum of the equipment. I will let you know how you can do with the minimum of the equipment. So, I request you to please like the video, share it to your friends, and subscribe it. First, starting with the basic of transformer. Transformer transmit the power from one source to the other by mutual induction without any change in frequency. Transformer follows the Faraday's law of mutual induction. According to the Faraday's law of mutual induction, it induces the voltage without any change in frequency. We should also be aware that transformers are not only used for transmitting the power from one source to the other, but it is also used for changing from delta to star or for change of the phase angle. Let us start with the test to be conducted before charging the transformer. First is the insulation resistance test. Insulation resistance test is done to determine the quality of the insulation of the winding. For a transformer, there is a low voltage side and high voltage side. The meter we are going to use depend upon the voltage. For example, here we have taken the LT side as a 415 volt. So there we will use 500 volt megahertz, while the ST side, if it is 11 kV or higher than that, we can use 5 kV megahertz. Now, for example, if a transformer is of 132 kV by 11 kV, then we can use 5 kV meter for both sides. We conduct the insulation resistance with respect to the one terminal and ground. We will also conduct with respect to one terminal and the other terminal. But mostly in the delta or the star connection, it is shorted. So it will be 0, or depending upon the meter, it can show less than 10 kilo ohm. Here I will represent one of the tests being done by me. We are using LT meter of 500 volt for measuring the LT sign. So While measuring from line 1 to ground, it is 3.5 gigaohm, and from the line 1 to line 2, it is less than 10 kilo ohm. It means that line 1 and line 2 is sorted. Similarly, for the line 2 to ground and the line 3 to ground. While doing the meter of the ST side, we should use 5 kV meter. With the 5 kV meter from line 1 to ground, it will be approximately 7 gigaohm or 8 gigaohm or 9 gigaohm depending upon the quality of the insulation. If it is less, then it's a point of concern. But again, as it is the star sign, so it is sorted, and line 1 to line 2 will be less than 10 kilo ohm. We will discuss about the acceptable values of insulation resistance in our next video according to the IEEE standard. Now about the PI and DAR test. PI is the polarization index test and DAR is the dielectric absorption ratio test. Both the tests are conducted to ensure the quality of the insulation, its cleanliness and dryness. But the TAR test is conducted only if PI value is less than 2 for a new system. For an old system, if the value is above 1.2, it is acceptable. DAR value is conducted for 60 seconds by 30 seconds. Its acceptable value is 1.25. So, in the DAR test, we will continue doing the measuring for 60 seconds and then for the 30 seconds, the value received for the both will be equal to 1.25 or 1.2 approximately. Here is one of the value of DAR test of the ST site which is done with the 5 kV meter. So line 1 to ground, when done, it is fine 1.25, 1.24 and 1.25. So it is not necessary that the value should come 1.25. It can be a little lesser, but it should be greater than 1. And the PI test is conducted for 600 by 60 seconds. It is also done to ensure the quality of the insulation. The best value for the PI is 2 and above, but anything above 1.5 is acceptable. Here I am showing you the PI report of the ST side. Because the transformer is new, so its value is good. It is above 2. But slowly and gradually, as the transformer gets older, there is some deterioration in the quality of the insulation, and similarly, there will be some reduction in the value. So then you can get the value from line 1 to ground up to 1.5. That is also acceptable. Here the line 1 to ground is 2.21, line 2 to ground is 2.67 and so on. It is, but the one thing to be kept noted is that it should be done for 600 second by 60 second. Similarly, you can do the PI of the LT side, but it should be done with the LT meter, that is 500 volt meter. Its value is also approximately 2 or 1.5, same. Now, here is the sample report of the DAR test of LT side. So, its value is from line 1 to ground is 1.43, line 2 to ground is 1.15. Anything above 1 is acceptable. Now, let us discuss about the magnetic balance test. Magnetic balance test is conducted to detect the fault in the core and to verify the imbalance in the magnetic circuit. It is also done to identify if there is any internal fault. I will show you the procedure how to do the magnetic balance test even if you don't have the costly equipment. In this test, we need to check that if we supply 440 volt in the line 1 and the line 2, then the voltage across the line 1 and line 3 plus the voltage across the line 2 and line 3 should be equal to 440 volt. So here we need to supply 440 volt in two lines, and we can check one line with the respect of the line which is not used. And if the summation is equal to 440 volt, then it is good. If not, then it's a matter of concern. Now, the voltage ratio test. The voltage ratio test is done to check the voltage ratio of the transformer, which depend upon the number of the turns of the winding. For example, you are using a transformer 11 kV to 415 volt, or someone is using a transformer 13.8 to 440, or 22 kV to 440, or 132 kV to 11 kV. So depending upon the transformer, the there is a difference in the number of the turns of the winding. So we will discuss how we can identify that the turns are proper or not. Let us consider a transformer with the 11 kV voltage at the incoming side and the voltage at the secondary side is 440. Now you insert 440 volt three phase supply at the ST side. You will receive a certain voltage at the LT side. So measure the voltage and then you calculate the ratio. If the ratio from 11 kV by 440 is equal to the ratio of 440 by the voltage you have received, then the voltage, then the turns ratio of the transformer is good. If not, then it's a matter of concern. Thank you, and I will come with the transformer commissioning part 2 very soon, and we will discuss the remaining tests need to be conducted before charging of the transformer. So I would like to request you please like, share and subscribe so that when I will make a video on transformer commissioning part 2 where I will discuss the remaining details. it will easily reach to you. I would also like to request you to kindly share it to your friends. Thank you. Take care.